In this video, I will be explaining about how to solve Section C, real-world applications of integration. This part consists of only one question, but there are three subparts, part A, part B, and part C that needs to be solved. First, I'm going to read the question and interpret what's the meaning, and then I'm going to solve part A, part B, and part C. Gilly, an economist, is studying a company's total revenue function, which models how revenue changes based on the number of products sold. The company's marginal revenue function, rate of revenue change per product sold, is given by derivative of Rx equals to 5x plus 7 over x squared plus x minus 6, where x represents the number of products sold in thousands of units. Our derivative Rx is the marginal revenue function, which describes the rate of change of total revenue per unit in percent x, where x is measured in billions of dollars per thousand units sold. However, due to market saturation, the company applies a progressive discount policy, which reduces the revenue per unit as more units are sold. For every additional product sold beyond x equals 5, the revenue per unit decreases by 5% per unit due to increased competition. The discount is modeled by the discount function dx equals to 1 minus 0.05 times x minus 5, which scales down revenue for x greater than or equals to 5. Gilly wants to determine the r. This should be delta R, I suppose. The delta R, which is total revenue increase as sales grow from x equals to 3 to x equals to 6,000 products. Since the discount only applies for x greater than or equals to 5, Gilly needs to consider two different revenue contributions. A. Explain the economic meaning of integrating derivative of Rx, and why the discount function is applied for x is greater than or equals to 5. Okay, and in this case, the lower and upper boundaries are written in this sentence. Grow from x equals to 3 to x equals to 6. X equals to 3 is the lower, and x equals to 6 is the upper boundaries. Now, the reason why the discount function is applied for x is greater than 5, because as it says here, the revenue per unit decreases by 5% per unit due to increased competition. Now for problem part B. For part B, it says set up the appropriate integrals to compute the total revenue increase. Hint, consider two regions. For sales between x equals to 3 and x equals to 5, revenue follows Rx, R inverse, no, derivative Rx without modifications. For sales beyond x equals to 5, the revenue is adjusted by the discount factor dx. So that means from 3 to 5, it's just Rx. And because we need to count the total revenue increase, that means we also need to add from 5, beyond 5. From 5 to, in this case, it says that it's asking for total revenue increase as sales grow from x equals to 3 to x equals to 6. That means the upper boundaries in this case is 6. And because it is adjusted by the discount factor, that means derivative of Rx times dx. Okay. Now, we can see that derivative of Rx in this problem is equals to this, right? So that means x plus 7 over squared plus x plus, oh yeah, this should be dx 5, 6, 5x, so plus 7 over same thing, x squared plus x minus 6 times dx is this one, right? 1 minus 0.05 x minus 5. Okay. Anyway, we can actually still expand this part by multiplying 5x plus 7 over x squared plus x minus 6 times 1, and 5x plus 7 over x squared minus plus x minus 6 times negative 0.05 times x minus 5. Okay, so that means 5x plus 7 x squared plus x minus 6 minus 5x plus 7 sorry, it should be times 0.05 x minus 5. Okay. Good. This should stay the same. This is the final model for the integral. Okay, now we're gonna solve for part C, evaluate the integrals, and interpret the result in terms of how market competition affects a company's revenue cost. That means for part C, what we have to do is integrate this, but before integrating, we need to reform this part, 5x plus 7. It's actually much more better. Oh yeah, it should be dx, yeah. It should be, I'm sorry, I forgot, it should be d times dx, and the same things goes with here. This one, and this one. 5x plus 7 over x squared plus x minus 6 should be rewritten into form of a over something plus b over something, because x squared plus x minus 6 is also equal to x plus 3 times x minus 2, and it stays the same, 5x plus 7 equals to, that means a is over x plus 3 and b is over x minus 2. Now, because we have to equalize the denominator should equals x plus 3 times x minus 2. That means we have to multiply this denominator by x minus 2 and this denominator by x plus 3. But we can't just do this because we also need to multiply the numerator by the same value. That means a should also be multiplied by x minus 2 and b should be multiplied by x plus 3, because x plus 3 over x plus 3 is equal to 1, x minus 2 over x minus 2 is equal to 1. We basically multiplied this part by 1. So at this point we can just focus on the numerator part. 5x plus 7 equals to a x minus 2 plus b x plus 3 equals to ax minus 2a plus bx plus 3b. Okay. Now somehow we need to group them into so that they have similar x value. Ax is grouped with bx, which should be equals to 5x, and minus 2a should be grouped with 3b, which should be equals to 7. 5 is equals to a plus b, and 7 is equals to negative 2a plus, 3b. Now we can multiply the upper part by 2 to make this into 2a. So 10 equals to 2a plus b 7 equal to negative 2a plus 3b. Because the 2a's cancels out, that means we have to add them, right? Because 2a minus 2a is equal to 0. So 10 plus 7 is equal to 17. This should be 0 and we don't need to write that. b plus 3b equals to... Wait, sorry, is it 3b? Oh, sorry, this should be 2b, right? 10 equals to a plus 2b. So 2a plus 3b equals to 5b. That means b is equals to 17 over... Oh, sorry. That means b is equals to 17 over 5. If you put the 17, the value for b, to this part, to b, we should get a equals to 25 over 5, because 25 over 5 is equal to 5, minus 17 over 5, right? 17 over 5 represents the value. And then we get 8 over 5. That's it. This is the final value for a, and this is the final value for b. Because from this, we can finally integrate this, right? We get the value of a, we get the value of b. That means, where should I write it? Maybe like in here. That means 5x plus 7 over x squared plus x minus 6 is equal to, what is a over 5 times x plus 3, right? X plus 3 plus 17 over 5, and then in denominator should be multiplied by x minus 2. Okay. And then what we have to do now is to integrate this, right? Because the lower boundaries is 3, 5, and then it's also 5, 6, right? Plus 5, 6. Should be 0.05 times x minus 5, and we should leave this as the way it is because it's hard to integrate. It's 8 over 5x plus 3 plus, I'm gonna delete this. (17) 5x minus 2 plus the integral of from 5 to 6 over the same thing, 8 5x plus 3 plus 17 over 5x minus 2 dx minus, it should be minus or negative this part, because this part is harder to integrate. So minus 5x minus x squared minus x plus 6 times 0.05 x minus x minus, what is it? 5. We should leave this as the way it is, and now we have to evaluate this part, both part, okay? So this is equals to 85, then x plus 3 plus 8 over 5 ln x plus 3, 17 over 5 ln x minus 2. For the upper boundaries is 5, and for the lower boundaries is 3, plus same thing, 8 over 5 Then x plus 3 plus 17 5 ln x minus 2. And for this case, the upper boundary is 6 and the lower boundary is 5. And this should be the same. So it should just stay the same. 5, 6. Dx. Okay. Eight over 5. Then, okay, 5 plus 3 is equals to 8. Plus 17 over 5. 5 minus 2 is equals to 3. Minus 8 over 5. Then 3 plus 3 equals to 6. And minus again, because we're counting the lower boundaries part, 17 over 5. Then 3 minus 2 is 1. Okay. Plus 8 over 5. Then 6 plus 3 equals to 9. Plus 17 over 5. Then 5 minus 2, 6 minus 2 equals to 4. Subtracts 5. 8 over, subtracts by 8 over 5. Then 5 minus plus 3 is equal to 8. And then subtracts again, 17 over 5. Then 5 minus 2 is 3. Okay. And then we can eliminate, over example, we can eliminate this part because this 2 cancels out. And I'm sorry, 17, 3. This should be 17 over 5 ln 3. 17 over 5 ln 3. And this also cancels out with this. We're left out with negative 8 over 5 ln 6 minus 17 over 5 ln 1 plus 8 over 5 ln 9 plus 17 over 5 ln 4. Okay. Because ln 1 is 0, so we can delete this. And then we're left out with only this 3. And because this 8 over 5 and this is also 8 over 5, we can what is it called, like groups them, which makes them turned into 8 over 5 ln 9 over 6, because the negative goes here, which is negative 1. 6 to the power of negative 1 equals to 1 over 6, and 1 over 6 times 9 is 9 over 6 plus 17 over 5 ln 4. We can actually evaluate this more, and then we will get the exact value, but since we don't have a calculator, we don't need to do that. So this is the final answer for part C.